I'm Anil Kumar. Welcome to my series on integration. In this video, we have taken a few trigonometric functions and their integrals. Now, trigonometric functions form the heart of integration. So this video is kind of very important. To begin with, we'll consider the three basic integrals related to trigonometric functions for sine, cosine, and secant square, whose integrals are given here. Most important here is to remember trigonometric identities. I'd like you to review trigonometric identities, and especially you should remember the following formulas given here. Sin a plus b, cos a plus b, cos 2x, cos 3x, sin 3x, combinations with product of sine and cosines, and the wave equation a cos x plus b sin x, which can be written as r cos x plus x minus alpha, where r, the magnitude, will be square root of a square plus b square, and angle alpha is between 0 to pi by 2, which is tan inverse of b over a. Right? So these are the basic things which you should remember. So make a note of all these formulas and then start solving the questions one by one. So let's have the very first example, which is we need to integrate sine square x dx. Now, to integrate sine square x dx, what we need to do is write it in terms of double angle, right? So amongst our formula list, you will notice that the formulas which are given at C and D relates cos 2x in terms of cos square x and sine square x. Now these formulas can be used to write sine square x in terms of cos 2x, correct? So whenever you get sine square x or cos square x, you can use these formulas, right? So the formula was, let's rewrite. We need to remember this, right? Cos 2x is 1 minus 2 sine square x. And you can isolate sine square x from here, writing this as 2 sine square x equals to 1 minus cos 2x. And therefore, sine square x will be equal to half of 1 minus cos 2x, correct? So replacing sine square x with half of this, what we get here is half of, then we can just multiply half with cos 2x also, we get half of cos 2x, correct, dx. Now it is simple. So integral of half is x, right? So we get x over 2. And here we get minus half. Cos 2x means sine 2x is the integral. Sine 2x. And this half gets multiplied, correct? Plus, of course, a constant c. So we get our result, which is x by 2 minus 1 by 4 sine 2x plus c. Clear? So that is how we have to use our trigonometric identities to find the integral. So that is the most important part, right? Now let's take part B, which is integral of cos cube x dx. So once again, we have to use our identity. So for cos cube x, we'll use the formula for cos 3x, isolate cos cube x, correct? So what we know here is that cos 3x is equal to 4 cos cube x minus 3 cos x, correct? So cos 3x can be written in terms of cos cube x and cos 3x. Now you can isolate this, right? So we get cos cube x as equal to, let me write first 4 cos cube x. We'll take it to this side, so it becomes cos 3x plus 3 cos x. And cos cube x finally can be written as 1/4 of both of them, which is cos 3x plus 3 cos x, correct? So I could write this integral here as 1/4 of all this. Cos 3x plus 3 cos x dx. Now 1/4 is a constant. I can take it outside and then find integral of these. So it is integral of cos of 3x plus 3 cos of x dx. See how simple it becomes, right? But you have to remember the formula. So what we get here is 1/4 of integral of cos 3x is 1/3 of sine 3x, and for cos x it is sine x, right? Plus of course a constant c. Now you can open the bracket and write this as 1/12 sine 3x plus 3/4 sine x plus c. Clear? So that is how you could find this integral. So if you remember the identities, it is not at all difficult, right? Now, sine x cos x. Now this formula you can actually derive from sine a plus b, right? So if I write sine a plus b plus, actually speaking, sine 2x is 2 times sine x cos x, correct? So that's the formula which we can use. Now sine x cos x will be half of sine 2x. Perfect. So let's replace sine x cos x with half of sine 2x. So we could write this integral of sine x cos x dx as equal to half of sine 2x. Okay. Now the integral is straight application of the formula, which is minus, and that is half of cos 2x. Okay. Plus c, of course. So we can get this as minus 1/4 of cos 2x plus c. Okay. So that is how we find this result. Now we need to do integral of square root of 3 cos x plus sin x dx. Now this could be written in the form of r cos. So we could write this as, we could write square root of 3 cos x plus sin x in the form of r cos x minus alpha, right? So where r is equal to, so this is 1, right? So r is square root of square root 3 square plus 1 square, which is 3 plus 1 or 4, and that gives you a positive value of 2. So r is always positive, right? And the alpha value, tan alpha, we can say, or we can say alpha is tan inverse. So let's write alpha equals to tan inverse of 1 over square root of 3, right? So 1 over square root of 3, you know those special triangles, 30, 60, 90, or pi by 6, right? I'm sorry, let me write pi by 3 here, right? So tan is 1 over square root 3. This is 1, 2 square root 3. So this angle is pi by 6. So that gives you alpha as pi by 6. Okay? So alpha is pi by 6. So we could write this integral as r is 2 for us, right? So it is 2 cos of x minus alpha. X minus alpha is pi by 6. Do you see that? So that is how you can actually rewrite your integral, and now you can apply the formula directly. So we get this integral as 2 times sine of x minus pi by 6 plus c. Do you see that? So that is how you can easily find the solution of this particular equation. Okay. Now let's take definite integrals now. So here we'll find now 0 to pi by 4 tan square x dx. Now we know the formula for secant square x, and we know 1 plus tan square x is secant square x. So tan square x is basically equal to secant square x minus 1. So this integral, I could write this as from 0 to pi by 4 So instead of tan square x, we can write this as secant square x minus 1 dx. Good. Secant square x, you know the integral, right? So now we can easily write down the integral. The limits lower is 0, the upper is pi by 4. And for secant square x, it is tan x, right? So it is tan x minus, this is x, and we get 0 to pi by 4. Substitute these values, so we get tan of pi by 4 minus pi by 4 minus, substituting 0, we get tan of 0 minus 0, right? So tan of 0 is 0 and 0 is 0. So we get that as our result. So we get tan of pi by 4 minus pi by 4, correct? And as you know, tan of pi by 4 is 1. So basically, we get this as 1 minus pi by 4 as our result, right? Now here is the last question. I would like you to pause the video, copy the question, solve, and then look into my suggestions. This time we need to find the integral from 0 to pi by 2 of square root of 1 minus cos 2x dx. So I hope you recall the formula for cos 2x, which we wrote as equal to 1 minus 2 sine square x, right? Now, you could rearrange, as we did earlier also, as sine square x we can find from here 1 minus cos 2x, and then we can say sine square x is equal to half of we can write this as 2 sine square x. We know 1 minus cos 2x, right? So we'll just replace 1 minus cos 2x with 2 sine square x. Perfect? Okay. So we can write this as from 0 to pi by 2. We have square root of 1 minus cos 2x is 2 sine square x dx. Now we're talking about limit from 0 to pi by 2. So sine square x square root is absolute value of sine x. It is positive, right? So it is 0 to pi by 2. We have square root of 2 and we have sine x dx. Integral of sine x is minus cos x. So I could write this as minus square root of 2 cos x. And we are working on the limit 0 to pi by 2. Correct? So now let's calculate the answer. Let me rewrite this as since minus square root 2 is independent of pi by 2 and 0, we'll write this as cos of pi by 2 minus cos of 0. Okay, so which is equals to minus square root of 2. Cos of pi by 2 is 0 and cos of 0 is 1. So we get square root of 2 as our answer. So this integral is a value which is square root of 2. Clear? So that is how we get this solution. Now I hope the steps are absolutely clear and we have seen with the help of these few examples how important the basic formulas are. In further videos, we'll take combination of trigonometric functions and we'll get into more details of substitution and finding some complicated integrals where trigonometric functions will be used. But I hope this video gives you a good foundation. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.